All right, let's jump right in. Today, we are cracking a code that, let's be honest, trips up pretty much everyone at some point: how to graph your data. It seems so simple, but it really all boils down to one critical decision.
You know that moment, right? You've got all your data, you've got this blank chart staring back at you, and you just freeze. X-axis, Y-axis, which one goes where? Does it really matter? Oh, it absolutely does. And trust me, we're going to make this super, super simple.
And there it is. That's the short answer. But just memorizing a rule, that's not how we do things. For this to really stick, we need to get into the why. Like, what even makes a variable independent or dependent in the first place?
So, let's meet the two main players in this whole story, and forget all the complicated textbook jargon. The best way, the easiest way to think about them is with just two simple ideas: the cause and the effect. Okay, first up is the independent variable. This is the cause. Think of it as the thing you change, the thing you control, or maybe something that just happens on its own, like time marching forward. The key thing is its value is totally independent of anything else you're measuring. And then we have its partner in crime, the dependent variable. This is the effect, and its name gives you a huge clue. Its value literally depends on whatever the independent variable did. It's the result, right? It's the outcome you're measuring to see what actually happened. So here's a super simple way to keep them straight. When you're looking at your data, just ask yourself a couple of quick questions. For the cause, ask, is this the thing I'm changing or controlling, or does this happen first? And for the effect, ask, is this the outcome I'm trying to measure? It's a little mental checklist. Okay, so theory is one thing, but let's make this totally crystal clear. We're going to walk through three really classic real-world examples so you can see this cause and effect thing play out.
All right, example number one. This is something pretty much all of us can relate to. Imagine you're looking at data for how many hours a bunch of students studied versus the scores they got on their exam. So, which one is the cause and which is the effect?
Let's think it through. The number of hours you study, well, that's the cause, right? That's the action, the input. And the exam score? That's the effect. It's the outcome that totally depends on how much studying you did. See? Simple.
Okay, let's try another one. Let's say a biologist is tracking how much food she's giving to some mice every day, and then she's measuring their weight after a month.
So what's the deal here? Well, the amount of food is the cause. That's the variable the biologist is controlling. And the mouse's weight? That's the effect. It's the outcome she's measuring. And it clearly depends on how much food they ate. Cause and effect. You're getting the hang of this.
And one last example to really lock this in. Picture a plant growing over time. We're keeping track of its age in weeks and its height in inches.
So in this one, time itself, the age of the plant, is our independent variable. Why? Because it just keeps going no matter what, right? We can't change it. And the height of the plant, that's our effect. Its growth absolutely depends on how old it is. Okay, I think we've totally got this. So now, let's put it all together.
All right, this is the moment we've been building up to. We know how to find the cause, we know how to find the effect. Now we can finally lay down the unbreakable, the golden rule of graphing. And I promise, after this, you are never going to forget it.
First, you take your independent variable, the cause, the thing you're changing or controlling.
And it always goes on the x-axis, the horizontal one. Just think of the x-axis as the foundation of your chart, running flat along the bottom.
Next, you take your dependent variable, the effect, the outcome that you're measuring.
And that always goes on the y-axis, the vertical one. See how perfect that is? The y-axis rises or falls depending on what's happening along the x-axis. It's a beautiful visual way to show that x is causing a change in y.
So you might be wondering, okay, I get it, but why does this rule matter so much? This isn't just some random, picky rule your high school science teacher made up. This is about speaking a secret, universal language. Look, this is a standard practice, a global convention. When you put the cause on the x and the effect on the y, you're instantly telling a story that anyone, from a scientist in Japan to a stock analyst in New York, can understand in a heartbeat. You're communicating the relationship clearly. If you get it wrong, well, it's kind of like writing a sentence backwards. Sure, someone might be able to figure out what you mean, but why make it so hard for them?
And that's it. That's the secret code. Independent variable, the cause, goes on the x. Dependent variable, the effect, goes on the y. You now officially speak the language of charts. So the only question left is,
What story of cause and effect are you ready to tell?